Hello, welcome to Production Grade with me, Chelsea Dover, and
Stephanie Dover.
this is, like I said, Production
Mhm.
Grade, a tech podcast where we will be posting tutorials, having technical discussions about tech and engineering excellence and career advice. And today we're going to be doing part one of our uh, first tutorial series led by Stephanie. Stephanie, do you want to kind of give a overview?
Sure, yeah. Today we are going to be doing an incident review RAG tutorial. So I wanted to create a tutorial for a RAG system. Obviously, us and a lot of our viewers are software engineers. So something that we care about a lot is incident review. So I thought that would be an interesting topic to cover in a RAG tutorial. So first of all, what is a RAG system? A retrieval augmented generation. So what you do normally for a retrieval augmented generation, you have context, usually in the form of documents. You feed this into an offline ingestion system. And so this will pull the document, it will chunk everything into like context windows. And then when you want to use this information to give a good answer to an end user, you grab the related information and just enough context window for you to get a really solid answer for maybe a question that they're asking. So for example, if you have an incident review, and I'll pull up an example incident review here. Um, these are not how I write incident reviews. These are just examples. But yeah, so for example, if you had an incident review, you might have the summary, you might have the root cause, contributing factors, you might have the five whys or something. And so each of these are kind of context segments. And then within these context segments, like this, root cause analysis, there's also context segments like deployment from January 14th introduced a new code path that didn't properly release data. So that is a context segment, right? That's something that gives you information about something like what day did it happen, January 14th, what specifically happened. That's a context segment. So there's a bunch of different context windows that might be like this entire thing. It might even be an entire document, but that'd be like a really big context window. It might be just like a sentence. It might even be part of a sentence. And so chunking grabs those portions. And then what you do is you store this in a vector database to be searched later on, and you store it by semantic meaning. So it's coupled together by semantic meaning. Um, and so when you retrieve it, you're looking for things that are related to what you're asking about. Um, and so what we're going to do today, because this is going to be a multi-part tutorial, we are going to go over just the chunking part. Don't look at that indexing flow. Don't look at it.
Spoilers.
That's later. That's the exciting stuff, okay? So what we're gonna do is we're gonna just talk about chunking. Do you think there's anything else I should say, Chelsea, before I jump into it?
No, are there any prerequisites or anything that people should
Yes.
know?
Absolutely. Yes. Thank you. Okay. So first of all, a lot of the stuff that I'm using is compatible with Python. So I'm using Metaflow. I'm using tick token. I'm using a lot of things like front matter. These are all Python things. Why Python? A lot of machine learning tools are very Python compatible. And so Python's kind of like a default language to use if you're going to be working with machine learning or AI or yeah, basically anything related. There's other options too. Some people use like TypeScript, but Python's normally kind of a default. So some other things to know, like what are the requirements for this project? Metaflow. What is Metaflow? So Metaflow is it's kind of like step functions, but obviously it's just something you put in one file. Um, and actually it has like a lot of things that are built in specifically for RAG systems. So first of all, if you look at it like a rack system simply, you might think, okay, there's these things that we do. We load the documents, we chunk the documents, we embed them, we put them in a database, and then we search them later on, right? So there's these steps. You could even put this in, let's say you could put it in like one big function, right? But these steps have kind of like logical breakpoints. Like they're related to each other, but they're not, doing the exact same thing. So that's okay for a demo. Um, but you might want to go ahead and use Metaflow anyway. So, okay, why Metaflow? So Metaflow is created by Netflix for machine learning workflows. It provides versioning, something that's very important for machine learning or any AI system. So it tracks every run, the inputs, output, the code, has artifacts, so automatic serialization and storage of Python objects. Resumability. So if it fails, a run can resume from the last successful step. Like scalability, steps can run on local machines, Kubernetes, AWS batch. Like you have choices rather than like other options that people might use might be like SageMaker, but you're kind of like stuck in a certain environment. Whereas if you use Metaflow, you can kind of deploy it anywhere. Um, Lineage, so full traceability from query answer back to source documents, things that are very important when you're creating a RAG system. You get to trace the versions, you get to trace exactly what happened. This can help you give you kind of like telemetry for outcomes. This can tell you if something went wrong, it can tell you exactly which thing went wrong. Um, so yeah, something that it's really nice and clean. I'll give you a little preview of what that looks like. So yeah, you can kind of see like these are Metaflow steps. These are things that are part of Metaflow flow spec steps. These are just parameters that you would send in when you're using like a CLI. Um, Current is something that you pass through the objects and it can give you the steps, and it can give you like you can have a card. This is something that creates kind of like a UI for Metaflow. You can also find you can hold data, you can hold error messages in it. Um, I'm not going to go too deep into what else there is with Metaflow because we could probably do like an entire thing on just Metaflow. But okay, let me go back to the requirements. We're using ChromaDB. That's going to be our vectoring database. Sentence transformers. So transformer. What is a transformer? So transformer is like the architecture for machine learning, like a machine learning model. It's not, so it's like a learning model without the learned parameters to put into it. And so like this is the architecture, and then when I actually use it, you'll see that there's let's see, what do I actually probably in embeddings, yeah. You see, when I actually use it, I pass it a model name. So this is the actual model, and that's like the parameters that were learned to put into this transformer to make it have a good outcome, basically. For it's the machine learning is basically the model, the transformer is like an architecture that supports the model. Transformers normally there's a lot of transformers existing online that you can find, like sentence transformer. That's something that I got online. You can find them in Hugging Face. You can find them within AWS. They have some libraries available. They have like a, a lot of a lot of transformers are available out there. It's normally where you would start if you're creating your own system. Um, OpenAI is what I'm going to be using. There's other things you can use. So for example, in this LLM provider, I show you can use OpenAI, you can use Anthropic. Really good choice here. You can use Olama. Olama, you can run it locally. You can also like it's free. So Olama is free. That's something that if you've just made like a little toy for yourself to play with, a little like LLM toy or whatever. Use a llama on your computer. You don't need to always use OpenAI or Anthropic. So yeah, let's see. Requirements more. Python front matter, I think it's parsing the markdown documents. I think is that's what I understand is what's happening here. So it's metadata like the title, data description, author. So yeah, it's helpful for parsing the markdown documents. Tick token, that is something that helps tokenize um, the chunks. So tokenizing is basically like encoding it. So if you want to encode the chunks, you can use tick token encoding for model. Um, and then rich, I'm actually not sure I'm using rich, but rich is something that can help you work with the with command lines. Okay. All right. So I think I gave you all the information that's helpful for that. We're using Python. Those are the requirements, why we're using which one. I don't know. Do you have any other questions?
No, I think we're ready. Dive in.
Okay. Before I get into this, I apologize that chunking is the first thing we're doing because that's just the first thing you do, but it is the most boring part. So yeah, my apologies for that. So let's see. Um, this is regex. Data classes is something where you don't have to use this in Python, but it just makes it so that you don't have to do like the init and stuff when you make something that's literally just like a data class. It's like a struct basically. Typing. So Python is not typed by default, but a lot of people do want to type it. So there's the iterator, there's optional iterators and iterable. Optional means that a parameter is optional. We went over front matter and take token. So that's what we have here that we're importing. Usually we have a data class. These are really similar to like a struct. This is just saying that this is the information that we are going to have, that this is the information that's stored on a chunk. Has the content, it has metadata, it has the index, the token count, and the section. So let's see. This is an incident chunker. That's just what we're naming this class. The incident chunker has, so in Python, for anybody who doesn't typically use Python, self is just what you pass to say, like in JavaScript, you might say this. I don't think, do you still have to do that in JavaScript? Like this dot,
No.
no, yeah. So you basically is just saying that like everything is attached to this class. So basically that's just, it's attaching it to the class. Um, the max tokens, so this is the token window that we've decided to go with for now. There's other token windows that you can choose. This is basically what sets the context window that we're going to chunk into. Um, so if you're using like Claude Code or something locally, you might see that it's running and it tells you how many tokens you've used. Often it goes into like 1.5 thousand, 2,000, so on. We're just doing, we have these tiny documents. We're going to do 512 tokens, context window. Overlap token, I guess we allow 50 token overlap. So I guess that means that when we chunk it, we might dip into the previous chunk. Model, OpenAI GPT 3.5 Turbo model for encoding. Um, let's see, max tokens. We have that overlap token. We are setting it as the encoder tick token, coding for model, and then that's the model. Okay. And then let's see, the count tokens. This is more of like a helper function. This is going to tell us, have we hit the limit? Basically, what's the token count currently, which you just get by getting the length of the encoded tokens. Parse document. Okay, so the parsing document, we are here. What's happening is we are going to take the markdown document. We are going to load the content from it. We are going to attach metadata. We are going to retrieve parts of the content. So right here, post is doing the front matter. It's saying load the content from the content is being read through a file reader, and then we're giving it the file name, and that's going to spit out metadata in the body. So if I go into what is parse document doing, we are getting this is creating remember those when we were looking at it earlier, they were basically like the titles of like this is the title, this is the description, this is, it's cutting it into the parts of the document. The metadata is something that I guess Post is parsing the metadata as well. And so we're going to kind of cut that up later on. If you look down here, there's title, incident, review, severity. So that does get cut up. But that's basically what it's parsing it into. Go up here. Yeah, you see we're adding a source file, swap file name, so that doesn't get added in here because it's not part of the file content. It's just the file path. And then we're returning that metadata and that content. So if we go down here, we are getting sections. We are doing extract the sections. So within sections, let's see, current section, current content. We are extracting the sections by chunks. Let me see, what are we doing here? I thought that this is where we would, okay, split long sections. Okay. So we are splitting the sections. These could be like the sections based off of this, where it's like these large paragraph sections. So we are splitting those up. We are just appending them to an array, and we are returning that array of all the sections. Once we do that, let's see, where'd you go? We are doing this create summary chunk. So this is the parts, and we're getting the summaries. Okay, and then yeah, documents. Oh, I'm in the wrong place. Okay, so we're having for each one of these, so you append the summary, the metadata, the chunk, count tokens. Oh, there it is. Okay, I'm like, something is missing here. Um, so we have the section name, the content, each section. This strip here is just saying like remove any white space from either side. Um, This is just if for some reason it was empty, you're going to continue. You're not going to store the empty data. So the section tokens, now we're counting the tokens and we're checking, are they max tokens or are they not? If they're less than the max tokens, we're going to, we have the chunk index that we're counting here. We're going to just shove that into the array where we're tracking the chunks. Otherwise, if it has hit the max, that's where we do this split long section. And basically, we're just splitting it until it's under the max tokens. Yeah, I mean, so that's actually it. That's all you do in a chunking document. I guess we can actually go into embedding. I feel like we have more than like how long have we been doing this?
Yeah, I feel like it's been like we have plenty of time if you wanna also
Okay.
go.
Do you have any questions about this very exciting chunking document?
Um, no, I mean it's been very self-explanatory. Also, you've explained it very well, so thank you for that.
Yeah. Okay. So after chunking, what we're going to do is embedding. Let's see. So we can actually kind of follow this indexing flow. This is the um, kind of the offline flow of grabbing the data. Um, so yeah, you see the first step is you chunk the documents. Um, Again, this is just storing the chunk documents. Um, This is kind of a fun thing you can do in Python. When you're looping through stuff. I guess it's kind of like a for each or something you would do in JavaScript, but it's just like fun syntax. Um, but yeah, so then it says the next step is going to be generating the embeddings. So we get to the embedding generator is what we created here. So that's what we're importing from here. Um, so let's go into the embeddings. Okay, so I guess I didn't say the word embedding before. So some viewers might be like, okay, that's cool. You didn't say embedding, you said chunking, and then you said vectorizing, and then you said put it in the vector DB. So what's going on here? Basically, that is actually what's going on here. We are doing similarity search. So we're marking the similarities. This is actually a really small file, but um, we are, I guess I didn't mention similarity. Um, Cosine similarity is would um how you would calculate similarity. The way that you vectorize something is going to be related to the semantic meaning. At its core, cosine similarity measures how similar two vectors are by looking at the angle between them, ignoring their magnitude. The formula gives a value between -1 and 1, where 1 means the vectors point to the exact same direction and 0 meaning they're orthogonal, unrelated. And -1 meaning they point to opposite directions. The formula is the dot product of two vectors divided by the product of their magnitude cosine AB divided by the magnitude of A times B. Um, what why it matters for semantics in natural language processing, words and sentences get converted into high dimensional vectors called embeddings. Okay. These are numerical representations where meaning is encoded as a position in space. Words with similar meaning end up close together, so dog and puppy might have vectors pointing in nearly the same direction, while dog and refrigerator would point in very different directions. Cosine similarity is the go-to metric for comparing these embeddings because it shares about because it cares about direction rather than length. A short document and a long document about the same topic might have vectors of very different magnitude, but their direction will be similar, and the cosine similarity captures that. Common uses include semantic search, finding documents similar to a query, recommendation systems, duplicate detection, and retrieval augmented generation in LLM applications. So that's what we're doing. We are creating lists of numbers and we are determining how similar these lists of numbers are. Um, yeah. So let's see what we have here. Sentence transformers shows its face again. We have NumPy. It's also NumPy. I can't decide if I want to call it NumPy or NumPy. Um, NumPy, what is it? Why are we using it? That is a good question. You create that. Um, it's a data structure for storing and manipulating large data sets of single data type. Fixed size, if you change the size, it actually just creates a new one. Um, and it's homogeneous and n-dimensional. Yeah. You'll see this a lot when you work with machine learning. Um, so yeah, we have typings. This again is just so that you can give types to Python. Okay, so this is our embedding generator. Generates embeddings using sentence transformers, white sentence transformers, open source, no API costs. We like that. It runs locally, good for data privacy, high quality embeddings, easy to switch models. Like literally, we set a model right there. So init, by the way, this on Python, like if you're using a class and you're not saying it's a data class, you need to init it like this. That's just how you start classes. Let's see,
I was
where's
curious.
yeah.
what are some alternatives to, do you mind scrolling up a little bit? Let me see
Mm,
what you called it. What are some alternatives to sentence transformers?
that is a good question. Okay, so alternatives to that. There's API-based solutions like OpenAI, Cohere, Spacey, um, words to vec, fast text, use, universal sentence encoder use. Um, it's like, yeah, there's some APIs you can use. Lightweight libraries, Spacey, Genzim, Hugging Face transformers plus pooling, BERT. But I mean, those are kind of like, yeah. Let's see. If I say specifically. Okay, somebody on Reddit, which sentence transformer is the best one for similarity search? This looks like an old one though. Check out the leaderboard. There's a Hugging Face leaderboard.
Ooh.
Yeah, English, multilingual, fine. I don't care. I don't care about your settings. Oh, error. I already broke it. Okay. Jasper token compression. See, there's like all of these. Hang on, see if I can share. Yeah, there's just like all of these. Mistral. These are models. Estella, Geo embedding, Cohere embed English. I mean, yeah, these are all the models that you can use instead. Hugging Face is a really good resource, by the way. If you were wanting to get into AI, you should look at Hugging Face. But yeah, there's a lot of alternatives. A lot of alternatives. Let's see. Mm. Okay. Do you have any other questions? Or did that answer your
No,
question?
yeah, yeah, thank you.
Okay. Let's see. So, okay, so generates embeddings we're going to generate embeddings using sentence transformers. But yeah, open source, no API cost, runs locally, high quality embeddings, easy to switch models. Okay, let's see. We have this default model that we're using. Um, and then the embedding dimension is coming from the model. So get sentence embedding dimensions is something we're getting from the model. Um, so embed text. Text is a sequence of string. We're doing a batch size 32. Um, we are doing show progress. So we're showing progress. So generate embeddings for a list of text, parameters, text, okay, list text strings, number of text to process at once. Larger is faster but more memory. 32 is good for most systems. Okay. Show progress, whether to show progress bar. And then it's going to return a NumPy array of shape, length of text, comma dimension. Okay. Um, So let's see. The embeddings, we are just encoding it. We have the text, we have the batch size, show progress, true. Okay, so we are just sending it all the text. Oh wait. And then the compute similarity, if you remember, similarity is basically how similar are these two arrays of numbers. So query embeddings, document embeddings. The query would be like the question that you're asking is the query. And then the document is the document that what we just chunked basically. So they return the similarity score of that. Okay, so the utility function for the quick embedding generation, create the embedder is just creating it. It's a factory function. I'm not sure we actually needed that, but here it is. Okay, let's see. Vector DB. So vector database operations using on the ChromaDB, that's just the DB that we decided to use. I think it was just kind of a random choice rather than because it's good. Like it's a vector database. So we're using ChromaDB. This module provides a clean interface for storing and querying incident review embeddings. What are we importing? So, okay, first of all, we're obviously not using path. Let me just like remove things we're obviously not using here. Some not good imports. So we are importing just JSON, date time, optional ChromaDB, and then the ChromaDB config settings. So incident vector DB. So the Chroma wrapper for the incident review storage and retrieval. It persists the storage for the production use, metadata filtering for precise queries. What the hell? Configure, I have some typos in here. So configurable similarity threshold. Okay. Persist directory. We're going to be storing it in the ChromaDB directory. I think you can see it up here. We have some data. These are obviously we can't open them. Yeah, we have that. And then the collection name will be incident reviews. Initialize the vector database. Okay. Okay. Basically just we have the persist directory and the collection name. And then we are giving it the same directory, anomalize. We're not using telemetry. And we're allowing the database to reset for testing. Okay. Let's see. Select collection, get or create a collection. This is basically just creating the collection. We're using the hierarchical navigable small world and cosine similarity. I did go over hierarchical navigable small world. It's hard to say, but I did go over that earlier. YHNSW. I do have it in the doc as well. So it's favored for its ability to provide extremely fast querying times while maintaining high recall. So let's see. We have the chunk IDs, which might remember we added in here before. It was literally just chunk index, I think is actually what we're using. Yeah.
And is the chunk you're just using index, is that more for demo purposes?
I think it's for demo purposes.
Okay.
Yeah. Yeah. So that's a good question, though. You're asking really good questions. Okay. There is some kind of semantics you would normally use for naming chunks. I was going to throw out just use a UUID, but I guess there are some like specific ways you might name it.
Okay.
But it kind of depends on which database you're using, like what's the default typical way. So yeah, that was a good question. As the documents with that array of text that we had before. The embeddings are, the vector embeddings that we created, and clean metadatas. Okay. Okay, I guess we're just dumping it. So let's see, what
Is
are
it-
we? Hmm?
Oh, I was just gonna ask because it looks like you have clean metadata and then you have clean metadata, but I'll just read through it.
Yeah, it's like clean metadatas, and then each one of them is like saying basically dump whatever object this is
Mm-hmm.
into this dictionary with the key um meta and metadata. Okay, so it's each metadata thing, just like dump it in here. Um, and then we are putting it as ISO format. So if is instance, if it's date, date time, got it. Okay. We're just formatting it so that it's a better format for the vector DB.
Mm-hmm.
So yeah, this is formatting. And then we are putting it in the collection. We are adding it to the collection in the CosmoDB, or sorry, the ChromaDB. Um, and then this is the ability to query it. Let me see something. Yeah, these are all just being used, I think, in the indexing and query flows. Um, so let's see. So query the vector database. I guess instead of going over the parameters up here, I'll do it down here because I feel like I've been saying them twice.
Okay, yeah,
So,
same.
okay, so query the vector database for the similarity chunks. Chunks, there you go. Typo. So the query embedding is the embedding of the query. That's something that yeah, I guess it's just like we don't really have the query yet, so we don't have that. So there's the end results. Um, so number of results to return. So this would be like at the top 5 results is what you're going to
Mm-hmm.
return here. So metadata filter, the severity. Okay, P1, where I say okay, where optional. Okay, and then where document full text filter on document content. Okay. Um, it returns a dictionary with IDs, document metadata, and distances. Okay. So okay, so now we're querying the collection. We're just sending it in basically those parameters that we just said. And then we're returning the result from that query. This just gets all the chunks from the collection. This one deletes all the chunks from a specific source file, resets the collection, um, just gets the account in the collection, the number of chunks in the collection, the format search results. Okay. Format ChromaDB results into a cleaner structure. ChromaDB returns nested lists. This flattens them for an easier use. So you just see it's sending in the results, so it's more like a helper function. And then just flattening them, getting the IDs, documents, all that. So we're only getting the first one because we are so ChromaDB returns a list of lists, one list per query. We only have one query, so we're only getting one.
Okay, yeah, that makes sense.
Yeah. And then this is just the formatting. Um, okay. And we're
Awesome.
just adding the similarity. So convert cosine distance to similarity. Um, yeah, just calculating that. Yeah. Okay. So I feel like we can kind of go through the whole thing actually just like this. And I'm like, why did I even like live code? Very
That's
quick.
nice, we're figuring it out.
Or, yeah.
Yeah. But yeah, thank you for going over this. I don't think I have any questions so far. Yeah, this was great.
Yeah, I
Is
feel like we're
there
gonna need feedback from viewers to be like, do you like this just code walkthrough? Do you also just like watch me live
mm-hmm.
code kinda? So there are some things like I guess I did kind of go over this is just setting up the provider for the LLM. There's other things that like I didn't actually cover the flow, even though I kind of referred to it. Because this is the offline indexing flow, and this is the online customer facing flow. They're not offline and online doesn't mean actually that it's offline. Like obviously it's an online service that's doing something. It's just it's not customer facing
Hmm.
offline. Yeah.
Yeah.
Okay, what were you gonna say?
Um, I don't remember. Yeah, but I guess we've been recording for a while, so
Mhm.
do we think that next time, I guess, do you want to go over really quick, just a quick preview of what, yeah, of
Talk
what
about
next,
next
yeah, what
time.
we'll talk about next time?
Yeah, that's a good idea. And then maybe we can still talk about a couple more things here because I feel like I don't know how fun or interesting this is for people. So we might be able to do like, all right, here's our tip for the day
Oh, yeah,
thing or
yeah.
um yeah, let's see. Okay. But yeah, so next time we'll go over the offline indexing and then the online query flow that kind of brings all of this together. And then we will actually test the system. So that's it. Thanks for joining us for that today. We have more for you. But that's it for the tutorial. Let us know what you think about this format. I also have a version where I recorded myself live coding, and you can watch that, or you can say if you like this just kind of coding walkthrough. This is available on my GitHub repo. If you go to github.com/stephDove, then you can see this incident review RAG tutorial. You can see the finished thing. You can kind of follow along. You can look at it yourself. Um, and then also I have this Notion document that explains more in depth about the entire tutorial, and you can kind of walk through it and type it out yourself as well. That is, I will link that under this video, and I will also link it in the repo for the completed code. Um, yeah, stop
Also, if you have
sharing.
any questions, feel free to, oh, okay. Uh,
No, go ahead. Sorry.
oh, sorry. I wasn't sure if you stopped recording or if you, okay.
Just stop
Uh,
sharing. Yeah.
okay, cool. If you have any questions, feel free to reach out and we will be happy to answer them. I say we, I'm not going to be able to answer probably if
I'll
it's,
push them over.
yeah,
Oh, no, I mean, I feel like you could answer about as well as I can.
I don't know. Well, I'll try my best. And then Stephanie will also try, but probably more successful to answer your questions. So yeah, do you have a tip for the day? Tech tip
Let
or
me
tech tool?
think. Because I did have some things. Some of them are like, look at this cute little project I made. Some of them are like, I have a cool prompt, but do I really want to share my prompt? Um, so I guess one thing, like a tip that you can actually, okay, I have a tech tip and then I have a non-tech tip.
Let's hear
Yeah,
it.
a couple non-tech tips. So the tech tip is just if you want to be really good at prompting, you might want to take time to tell the LLM what it is. So you don't just say, do this thing, but you might say, you are a staff level software engineer. You need to go implement this thing, blah, 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 blah. Like give it details, but also tell it, like, give it a role to play, like it's having a role to play. Um, a fun thing is that I had Claude Code make this cute little, maybe I'll just pull it up. But yeah, so I don't always have the best social skills. I know that's like surprising for everybody in the world to hear.
Not even,
Not,
girl.
but anyway, I was thinking like maybe I need to like make a little app of like how to reframe things. And then I was like, I'm just gonna ask Claude Code to make this for me. So this is this like tiny little app that I made in 10 minutes. Um, but you can run it locally with Olama as well, so it's free. But like for example, I said, I need, first of all, it can listen into meetings or can just like listen to you and have like a wake up phrase. So my wake up phrase was like, so here's the thing. And then I tell it, I need to tell my cat, no, they can't have any more treats. And then it says, okay, say it this way. I'm feeling a bit overwhelmed with the number of treats I'm giving out, and I think it would be great if we could limit them going forward. I changed the tone from being about the cat to being about personal responsibility. Like, dang, okay. But then it's like, by the way, this is not about like anybody that I'm working with or anything. It's just, yeah. Like I paired with another engineer, but they're taking 1 week to review PRs. Maybe they could review them faster. I'm hoping we can streamline this review process for PRs. Have we discussed any opportunities to accelerate feedback on code reviews? Okay, that's legit. That's legit. So yeah, it's basically just something you can use to reframe if you're somebody who's kind of blunt like me and just kind of like we're gonna say that the tactful way. Um, my other tip of the day. Well, okay, now I have two, but I'm like, can I even say that? First of all, how to find out if you have tongue tie. Do you have tongue tie?
No, I don't think so. I've checked before.
Have you? Because it's like you have to do this thing where like yeah. It looks so scary.
Censor that. Censor it.
I mean, okay, it looked weirder when I did it, but it was like you do this like slow, like horror movie, like. But no, that is what you do. You open your mouth up all the way.
And yeah, if you have it, your tongue can't
Yeah, it prevents you from doing the same. So like you fit your fingers in the side of your mouth, figure out how many you have. How many you could fit.
fit like two and a half.
Basically here, three. And then if you put your tongue at the front of your teeth, I did like 2.5 almost. Yeah. Like if it's more limited.
Well, I have TMJ. I have jaw issues. So
Yeah, usually you that's what I'm surprised because usually if you have tongue tie, you have TMJ because what's happening is and we just get to constantly mew, so it's great. Like for me, to have my tongue sit up in the palate and back, basically I have to like it's more natural for my mouth to be completely closed and kind of clenched.
yeah, my mouth is like pretty much always clenched too.
Yeah, we're always mewing, right? But your tongue is supposed to be sitting in your palate, but it's also supposed to be touching your front teeth with your mouth slightly open.
Yeah, I my
It's
mouth is
hard.
never slightly open.
All right. Yeah, I have to remind myself to do that. Yeah.
Yeah. I have jaw issues. My tongue, I think, is also like too big for my mouth. I don't know. I think I have a small mouth, but I also have like a regular sized tongue. So my
Like
tongue,
it's trying to escape, right?
yeah. So my tongue, like literally, what does someone call it? Like, like it looks like a dumpling. It's got like ridges around, like teeth
Oh yeah, it's
ridges.
got that. Yeah,
Yeah,
yeah.
my cheeks.
Um, your cheeks. Oh, yeah.
Mm-hmm.
I got the rich cheeks. So I was chomping on them. They're so yummy.
Mm-hmm.
The other thing I keep on trying to practice this, but I have so I do vocal fry, and I've been trying to not do that. And then also it's just like I talk in the back of my throat usually, kind of like relax. It's like when I'm relaxed talking, I'm talking kind of like the strain is here. And I was on ChatGPT. I was like, how do I get rid of doing that? And like also sometimes when I laugh, like I laugh, like back in the back of my throat. And it's like I was trying to do like a yes, like a cute little laugh. Yeah, like that probably. I mean, yes, I was like, how do I not do that? And I was like, you need to project up and out. I'm like, okay, I need to talk up and out. And it feels like I'm now very serious and I'm yelling at people. But that's my new goal is to be able to like talk like that and make it feel natural.
Nice. Yeah, I know I have major vocal fry. I need to get that in check too, but I can't help
Up and yeah.
it.
Yeah. Do up and out, up and out.
Up
They
and
just,
out. That
yeah,
was
so it's kind of like it raises your baseline tone of like your baseline pitch a little, but it's like up and out. Yeah. I don't know. Could you hear a difference between this and this? Like this one, I'm projecting up and out. This one, I'm relaxing in the back of my throat.
I can actually hear a difference. Yeah.
Okay,
It's
yeah.
yeah. It's
I mean,
yeah.
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 Yes.
Yes.
Okay, what
Yeah.
do you? Yes. I feel like I'm putting on a performance. Yeah, okay, give your tips.
Um, oof. I don't have tips. I've been so busy. Let me think.
Tell us what you've been doing. Have you been sewing? Did you sew a nice dress lately? Have you
Um, Work and
Mm,
packing. Yes.
packing? Yes.
And
My sister's getting married in India.
yes, not this
I
sister, other sister.
yeah, our other sister is getting married in India. She's already married.
I don't I'm not wearing my ring, but it's there.
Mm,
I
There in her
would
heart.
like a ring, I would like a ring, I would like a diamond ring, I want a wedding finger.
Yeah. I thought, wait, what was that? Was it a TikTok
It's
or
a
what was
song. It's a song. Where's my husband? I
Where's
would
my
like a
husband?
ring. I would like a ring. I would like a diamond ring on my wedding finger around like a big and shiny diamond that I can wave around and talk about it.
Gorgeous. I don't know if that's gonna replace You Better Work Bitch for me, but You better work, bitch.
uh oh, I guess one thing is open air headphones. They're actually
Hmm.
really cool. I have issues with a lot of earbuds because they
Hmm.
don't really stay in my ears, hence why I'm holding onto these headphones the
Oh
whole
yeah.
podcast.
It makes you look really serious and cool though.
Yes. Oh, what?
Yeah.
Uh but yeah, headphones just in general are not very comfortable for me in my ear. But I recently got open air headphones and they're really comfy. And I think because there's like earflow to your ear, I think they're better for hearing.
Hmm.
I'm noticing the vocal fry now. They're better for hearing.
Right? Now, isn't it kind of like whenever you catch yourself doing it, you're like, I better restate that and
Yeah.
say it up and out.
Yeah. Uh yeah, they're better for your hearing health, your ear health. So that is my tip. Not very technical, but
I like it. Hmm.
yeah.
Cool. Do you want to show him your art or something?
I I don't have I did finish editing. It's in the drive. That's also what I've been doing.
Oh, nice. Our
So
first episode.
our
Yeah.
first episode, which you can, if you haven't seen it, check it out.
Yeah, we'll post it on LinkedIn. We'll post it on production grade YouTube channel.
Mhm.
I think that's about it.
Yeah.
Yeah. Yeah.
Cool. Cute. Loved it. Thank you, Stephanie,
Thank you,
for
Kathy.
going through this. And I'm super
Okay.
excited to see the next installment of this
Thank you.
tutorial.
Thank you for asking really good questions. Like that was really helpful, and I feel like it made it so that all of us got more technical depth. Me as well, and the audience. So that's great.